Strap in, cosmic dreamers, as we launch into the mind-bending realm of the multiverse hypothesis, a wild ride that asks, are we truly alone in reality? Welcome to an electrifying journey through one of the most provocative ideas in modern science, where parallel universes, infinite realities, and alternate versions of you might just exist beyond our cosmic horizon. What is the multiverse? Could other universes hum alongside ours? And what does this mean for our place in existence? Get ready for an epic adventure that will stretch your imagination and leave you buzzing with curiosity. Let's dive into the multiverse hypothesis together. Picture our universe, a vast expanse, 13.8 billion years old, brimming with galaxies, stars, and planets, all born from the Big Bang. It's everything we know, a cosmic stage where life, including us, plays out. But what if this is just one universe among countless others? The multiverse hypothesis suggests our reality is not unique but part of a grand collection of universes, each with its own laws, constants, and stories. Some might mirror ours, with slight tweaks. Maybe you're a rock star in one. Others could be wildly alien, with different physics or dimensions. This idea, rooted in physics, cosmology, and philosophy, challenges our deepest assumptions about existence. Doesn't that spark a thrill to explore what lies beyond? The multiverse concept isn't new, but its scientific roots grew in the 20th century. Ancient philosophers, like the Greeks, mused about multiple worlds, but modern ideas stem from physics. In 1957, Hugh Everett III, a young physicist, proposed a radical interpretation of quantum mechanics, the many worlds interpretation. Quantum mechanics, governing atoms and particles, shows reality at tiny scales is probabilistic. Particles exist in multiple states until measured. Everett suggested each measurement splits reality into parallel universes, one for each outcome. Flip a quantum coin, and two universes form, one for heads, one for tails. This idea, initially dismissed, later inspired multiverse theories. Can you imagine reality branching endlessly? Let's dive into quantum mechanics to grasp this. In the 1920s, physicists like Werner Heisenberg and Erwin Schrödinger developed quantum theory, revealing a world of uncertainty. A particle, like an electron, isn't pinned to one spot but exists in a superposition of all possible states, described by a wave function. Measuring it collapses the wave function to one state, say, position A or B. The Copenhagen interpretation, the standard view, says collapse is random. Everett's many worlds interpretation, though, claims no collapse occurs. Instead, the universe splits, one reality where the electron is at A, another at B. Every quantum event, from a photon's path to a cat's fate in Schrödinger's thought experiment, spawns new universes. Isn't that a dizzying take on reality? The many worlds interpretation is one multiverse flavor, but others exist. Inflationary cosmology, born in the 1980s, offers another. Proposed by Alan Guth, inflation says the early universe, right after the Big Bang, expanded exponentially, faster than light, smoothing it out. This explains why our universe is flat and uniform, as seen in the cosmic microwave background, the Big Bang's afterglow. But inflation might not stop everywhere at once. In eternal inflation, proposed by Andre Linde, pockets of space cease inflating, forming bubble universes like ours, while others keep ballooning. Each bubble has unique properties, different constants, particles, or dimensions. Our universe is one bubble in an infinite, frothy multiverse. Can you picture this cosmic foam of realities? String theory, another pillar, fuels multiverse ideas. Developed to unify general relativity and quantum mechanics, it posits that particles aren't points but tiny, vibrating strings in 10 or 11 dimensions, most curled up at subatomic scales. String theory allows countless configurations for these dimensions, each yielding a universe with distinct laws. Estimates suggest 10 to the 500 possible vacua, or universes, each with unique physics. Some might lack gravity, others forbid atoms. This string landscape suggests our universe's constants, like gravity's strength, are one of many possibilities. If true, we live in one sliver of a vast string multiverse. Doesn't that make our reality feel like a cosmic lottery? The anthropic principle ties to this. Why is our universe fine-tuned for life? The gravitational constant, electrons' charge, and other numbers are just right for stars, planets, and us. Tweak them slightly, and galaxies collapse or atoms fail. Multiverse theories suggest countless universes exist, each with random constants. Most are lifeless, but we're in one where life can arise, because we're here to observe it. This anthropic reasoning explains fine-tuning without a designer, but critics call it untestable, a philosophical dodge. Still, it's a compelling lens for why our universe seems special. What do you think, luck or a deeper reason? Let's explore types of multiverses, as theorized by physicist Max Tegmark. Level 1 is simple, our universe is infinite, so beyond our observable patch, 93 billion light-years wide, repetitions occur. Somewhere, an identical Earth exists, with another you, because infinite space allows all arrangements. Level 2, from eternal inflation, involves bubble universes with different physics. Level 3 is Everett's many worlds, splitting at quantum events. Level 4, the wildest, includes all mathematical structures as universes, where any consistent math yields a reality. These levels, from spatial repeats to abstract realms, stretch our minds. Which multiverse sparks your wonder? Evidence for the multiverse is tricky, as other universes may be inaccessible. But clues exist. The cosmic microwave background, mapped by satellites like Planck, shows the early universe's ripples. Anomalies, like a cold spot for odd alignments, might hint at collisions with other bubble universes during inflation, though dust or chance could explain them. Gravitational waves, ripples in spacetime, could carry inflation's signature, detectable by future missions like LISA. In quantum experiments, entanglement, where particles share states across distances, echoes many worlds branching, though Copenhagen fits too. String theory's math predicts multiple vacua, but no direct test confirms them. The multiverse remains speculative, yet tantalizing. What clue might tip the scales? Let's tackle testability, a core issue. Science demands predictions we can verify, but other universes seem beyond reach. Eternal inflation predicts CMB patterns, like curvature or bubble collisions, but these are faint and ambiguous. Many worlds claims all quantum outcomes occur, but we only see one, making splits invisible. String theory's vacua are mathematical, not observable. Critics, like physicist Sabine Hossenfelder, argue the multiverse strays into metaphysics, unprovable by experiment. Defenders, like Sean Carroll, say it's a natural extension of known physics, testable indirectly via inflation or quantum effects. This debate fuels passion, science or philosophy. What's your take? The multiverse intersects with dark energy, the force driving our universe's accelerating expansion. Discovered in 1998 via supernovae, dark energy makes up 68% of the cosmos. Its value, a tiny 10 to the minus 120 in Planck units, puzzles physicists. Quantum theory predicts a monstrously larger number. String theory's multiverse offers an answer. Among 10 to the 500 universes, some have this weak dark energy, allowing galaxies and life. We're in one because it suits us, per the anthropic principle. But this explanation frustrates some, dodging why our universe is so. Could dark energy unlock multiverse clues? Black holes spark multiverse intrigue. Some theorists, like Nikodem Poplawski, suggest black holes birth new universes. Inside a black hole's singularity, where physics breaks, a new Big Bang might erupt, spawning a universe with tweaked constants. Wormholes, theoretical tunnels in spacetime, could link universes, though they need exotic matter to stay open. These ideas, tied to general relativity and quantum gravity, are speculative, but black holes, real, observed objects, make them tantalizing. The 2019 Event Horizon Telescope image of a black hole fuels such dreams. Could each black hole hide a universe? Let's explore philosophical angles. The multiverse challenges what reality means. If infinite universes exist, every possible outcome happens. Every choice you didn't make plays out elsewhere. This raises questions of identity. Are you unique, or just one of infinite copies? Free will feels shaky if all paths occur. Some find this liberating. Every dream lives somewhere, others, unsettling, dwarfing our choices. Philosophers like David Lewis, with modal realism, argue all possible worlds are as real as ours, a level 4 multiverse echo. These ideas blend science and soul-searching. How does an infinite multiverse shape your view? Science fiction loves the multiverse. Stories like Marvel's Multiverse Saga or Philip Pullman's His Dark Materials weave parallel worlds, where heroes hop realities. These draw from many worlds or inflation, dramatizing alternate histories or alien physics. Sliders and Rick and Morty play with infinite versions of characters, echoing Level I's repeats. While fictional, they ground ideas in human stories, sparking curiosity. Real multiverse theories, though, stick to math, not portals. How do these tales fuel your multiverse dreams? Cosmic implications are vast. If the multiverse exists, our universe isn't special, just one of many. Life might thrive elsewhere, with alien biologies under strange laws. Exploration, via wormholes or quantum tech, becomes a multiversal quest. Physics evolves. String theory or quantum gravity might unify relativity and quantum mechanics, proving a multiverse. But risks loom. Untestable theories could stall science, and infinite realities might dilute meaning. The multiverse redefines our cosmic role, from lone actors to players in an infinite cast. Doesn't that expand your sense of wonder? Challenges test us. The multiverse's unobservability frustrates. How do you prove other universes? Inflation's predictions, like CMB anomalies, are ambiguous, muddied by noise. Quantum splits in many worlds evade direct tests, as we're stuck in one branch. String theory's vacua overwhelm, offering too many options to pin down. Dark energy's fine-tuning begs explanation, but anthropic reasoning feels circular. Yet, physicists innovate: new telescopes, quantum experiments, wave detectors. The universe dares us to probe its depths. What breakthrough might confirm a multiverse? Let's bust myths. The multiverse isn't proven, it's a hypothesis, rooted in math, not fact. It's not a sci-fi portal you walk through, wormholes are theoretical, not real. Not all universes are livable, many lack atoms or stability. And no, it's not just imagination, Everett, Goose, and string theorists grounded in physics. The real story: quantum splits, bubble universes, string landscapes, outshines fiction, blending rigor and awe. What surprises you most? The future dazzles. The Simons Observatory and CMB-S4 will map the cosmic microwave background, hunting inflation's traces. LISA, a space-based gravitational wave detector, might catch Big Bang ripples, tying to multiverse origins. Quantum computers could simulate many worlds' effects, probing splits. String theory's math, if testable, might narrow vacua. We'll chase dark energy's nature, refining constants. Could a CMB anomaly prove a bubble crash? Might quantum tech unveil parallel realities? The multiverse beckons, full of promise. What does this mean for us? The multiverse hypothesis, with its infinite realities, ties us to the cosmos's deepest questions. Are we one of many? Do other yous exist? Your atoms, born in stars, link to this grand puzzle. From Everett's math to sci-fi's dreams, curiosity drives us. We're explorers, chasing truths beyond our universe. As we near the end, let's gaze ahead. The multiverse, a tapestry of realities, dazzles with possibility: quantum worlds, bubble universes, string realms. New tools, math, and dreams will probe it. What realities hum beyond ours? How will they redefine existence? The cosmos calls, full of wonder. What questions stir your mind? Thank you for joining me on this epic dive into the multiverse hypothesis, asking if we're alone in reality. I hope your curiosity blazes. If you love this cosmic adventure, hit that like button, subscribe, and ring the bell for more journeys into the unknown. Drop your thoughts in the comments. What blows your mind about the multiverse? What mystery should we explore next? Until then, keep looking up, keep wondering, and let's unravel the universe together. See you in the next video, Cosmic Explorers.